This is example 3.6.1. It says a rock is dropped from a cliff that is 100 meters high. Determine the magnitude of its velocity as it strikes the ground. So we're trying to figure out what the final velocity is. We know that it's going to accelerate because we're dropping it. And it looks like there's not a whole lot of information given to me. However, there's a lot of hidden information in this particular case. So we're going to do our if that. And we're going to see what we've got. So the first thing it says is a rock is dropped from a cliff 100 meters high. So for some reason a lot of people want to put 100 meters, but the displacement is actually negative 100 meters because it's going to start 100 meters above the surface of the ground at 0. And so it's actually going to fall in the negative direction 100 meters. Okay, since it's under the influence of gravity, we can also say that the acceleration due to gravity is negative 9.8 meters per second squared, because we're going to assume that this is on the Earth. The other thing that you have is you say the rock is dropped. By saying that it's dropped, you're indicating that its initial velocity is 0. So now we can apply our principles of if that. I'm trying to solve for the final velocity, so I'd say initial, final, distance, and acceleration are covered. So what I don't have is time. So the equation that I have that doesn't have time in it is A equals Vf squared minus Vi squared over 2d. So now we have our initial velocity was 0, we have the acceleration is negative 9.8, and we're trying to figure out what's its velocity as it strikes the ground. So we start out with our equation, A equals Vf squared minus Vi squared over 2d, and we're going to multiply both sides by 2d. When we do that, we get 2ad equals Vf squared minus Vi squared. So now we're going to add Vi squared to both sides, and what we're going to get is Vi squared plus 2 AD equals Vf squared. We're going to take the square root of both sides, and we're going to get Vf, and then we're going to go ahead and plug in our numbers. We're going to get Vf is equal to the square root of Vi squared, 0 squared, plus 2 negative 9.8, and this is where that other negative term, this negative 100, comes into play. These two multiply together and they're going to become a positive number, so that allows me to take the square root. If these two if this is negative and this is positive, it doesn't work. You'll get an imaginary number. So 2 times negative 9.8 times negative 100, we take the square root of that and we get 44.3. But remember, whenever you take a square root, it's positive or negative. So it's up to us to decide what is the direction of this as we drop it. So when you take a rock and you drop it, when it gets to the bottom, it should still be moving down. So the best answer for us would be negative 44.3 meters per second.